In this video, you're going to learn how to hash users' passwords before saving them to the database, which means a user is still going to send the plaintext password in the post user's request. You will still validate the plaintext version, making sure it's of a certain length. Then you're going to hash it, salt it, and store it in the database. This is much more secure than what we're currently doing, which is storing that plaintext password, which is a terrible idea. Now, in order to get this hashing done, we're going to use an algorithm called bcrypt. Bcrypt is fantastic because it is super secure and it has salting built in, which means you don't need to go through the effort to write the code to salt your passwords. You can simply take advantage of the bcrypt algorithm. Now, to install this, over inside of the terminal, we're going to run npm i with the module name. There are quite a few different variations of the bcrypt algorithm on npm. I always use bcrypt.js. This library is completely written inside of JavaScript, which means there are no dependencies. There is also a library called bcrypt, which has the same API, but I've run into so many problems with that, especially across operating systems. Bcrypt.js at the most recent version, 2.3.0, and I'm going to tack on the save flag to add it to my package.json file. Now, before we actually add this to the application, let's just play around with bcrypt really quickly over in the hashing.js file. Over inside of hashing.js, we can comment out all the other examples we have. You can feel free to delete these or keep them. This is going to be one of the last times we actually edit this file. Up at the very top, we are going to load in the algorithm. Let's make a constant called bcrypt and set it equal to the return result from requiring bcrypt.js. Now, if you want to look at the docs, you can always head over to npm. Let me just point you in the right direction really quickly. Bcrypt.js npm should get you the right result, and here it is. It's the npm package bcrypt.js. This module has fantastic documentation, so if you ever want to read more about the algorithm or see all of the other methods that are available to you, it's all defined here. Now, in order to use bcrypt.js inside of our hashing file, we need to do two things. First, we have to get some sort of value. Let's make a variable. We'll call it password, and we'll set it equal to 123ABC exclamation mark. Then we're going to go ahead and actually hash it. Now, in order to hash a password using bcrypt, we have to call two methods. One is gen_salt. This is going to generate a salt we can use to salt our password. The other one is the hash method, which actually goes through the hashing process. Now, salting passwords is really important. Imagine I have a password like password1. If I hash that without salting it, I'm going to get the same result every time. Let's just say, for example purposes, the result is MMNN. Now, obviously, that's not the case, but this is just an example. Now, the problem with this strategy is someone can pre-compile a list of passwords and hashed values, and they can use that as a lookup table. They can say, hey, I've ran through 15,000 English words, including password1, and I have the hash values for all of them in an object, where the key is the password and the value is the actual hash. All they need to do is find the one that matches MMNN, and boom, they have your password. When you salt a password, you're adding a bunch of random characters to that hash. This means that even if I hash the same password multiple times, I'll get a different result. So no one can pre-compute a table to look up the passwords. Now, in order to generate that salt, we're going to call bcrypt.gensalt. Gensalt takes two arguments. It's an asynchronous function. The second argument is a callback function, and the first one is the number of rounds you want to use to generate the salt. Bcrypt is inherently slow, and that's a good thing. It's going to prevent brute force attacks. We're going to use 10 as the number of rounds. The bigger the number, the longer the algorithm is going to take. I know people who use 120 rounds. They intentionally make bcrypt take longer so no one can brute force these calls. Now, obviously, adding unnecessary length to your API is not a great idea, but when it comes to passwords, it definitely is. This is going to prevent someone from making a million requests every second. Instead, they might be able to make a few hundred, which is going to greatly reduce the chance that they'll be able to crack a password. Now, we're going to generate this salt, passing in our callback function. We'll get an error and a salt value. And then we can go ahead and finish off the arrow function. And in here, this is where we're going to actually do the hashing. Bcrypt.hash. And inside of here, we're going to pass in three arguments. The first one is the thing to hash. In our case, we're going to be hashing the password. We have that variable declared right here. The second is the salt to use. We have the salt we just generated via the function up above. The third is the callback function. The callback function is going to get called with an error, if any, and the hash value. This hash value is what we want to store inside of our database. We don't want to store the password. We want to store the hash. Let's go ahead and log this to the screen using console.log and simply passing in hash. Then I'm going to go ahead and run the hashing file inside of the terminal. I'll use clear to clear the terminal output, and we can run node playground/hashing.js. When I do this, I get my hashed value. Now, this hashed value has a lot of really awesome information stored inside of it. It has the number of rounds. You can see we have 10 right here. It has the length for the hash and the salt. All of that information is stored right inside. There's no reason to have two things, a salt and a password value in the database. That's why bcrypt is so fantastic. The salt is built in, and there's nothing to worry about in terms of storing a separate value. Now that we have this hash, we can look at how to actually compare if this hash equals the plain text password. This is what we're going to do when someone logs in. To illustrate this, I'm going to create a variable called hashed password. I just copied the password to the clipboard. I'm going to paste it inside of quotes right here. And now we're going to try to compare this value to the string 123 ABC exclamation mark. To compare values, we're going to go ahead and use our final function off of bcrypt. This is bcrypt.compare. Bcrypt.compare takes the plain value, the hash value, and then it lets you know if those two equal each other. The first argument to compare is the plain string. In our case, we have our plain password stored in the password variable. The second argument is the hashed value. We have that in hashed password. And the third argument, that is simply a callback function. It might get called with an error, and it is going to get called with a result. The result is either true or false. It's true if the password matches the hashed password, and it's false if they do not equal each other. Now we can finish off our arrow function, and we can go ahead and print the value of response to the screen using console.log res. And we can comment out our previous calls to gen, salt, and hash since we already have the hashed value right here. Now I can save hashing.js, and over inside of the terminal, we can rerun the file. I'm going to rerun the file, and what do we get? We get true. We're getting true back because the password 123ABC exclamation mark, does indeed equal this hashed value. Now, if we were to change the password, setting it equal to something else, like 123 exclamation mark without the ABC, this is going to result in false. If I rerun the file, that's exactly what we get. And this is what we're going to do when we log in a user. We're going to fetch the value out of the database, the hashed password value. We're going to compare it to the plain text value they gave us, and then we'll be able to use this response variable to determine whether or not the password was correct. Now that we know how to use bcrypt, we're going to add it inside of our user model. We're going to be hashing all of our passwords before we save them. Now, in order to do this, what we're going to explore is something called Mongoose middleware. Mongoose middleware lets you run certain code before or after certain events. For example, an update event. We can run some code before we update a model. We can run some code after we update it. In our case, we want to run some code before a document is saved. Before we ever save that document to the database, we want to make sure the hashed password is in place. To get this done, we're going to explore the documentation real quick so you know where it is. There is a ton of middleware methods that we won't be using, but you should know where they are. Mongoose middleware is going to bring you to that documentation page. Here we are, we have the docs middleware page, and up above they outline all of the different events. We have an init event, validate, save, remove, and countless others. Well, not countless, but quite a few. If you scroll down below, you can get a quick idea about exactly how it works. Right here, we have some schema, pretend it's our user schema, and what we do is we attach an event. User schema.pre runs the code before the event is save, and right here we actually run the code. We call next when we're done, and that is when the model gets saved to the database. This is exactly what we're going to do, only inside of the callback, we're going to be hashing the password. To get this done, we can pull up Atom and we can start modifying our user schema. Down near the bottom of the file, just below find by token, we're going to attach something else to user schema dot pre. This is going to run some code before a given event, and the event we want to run code before is the save event. Before we ever save the doc to the database, we want to make some changes to it. Now I am going to be using a regular function once again because we are going to need access to the this binding. So I'll use the function keyword, and this is going to get called with the next argument. You have to provide this argument and you have to call it somewhere inside of your function. If you don't provide it and you don't call it, the middleware is never going to complete and your program is going to crash. Inside of here, we're going to get access to the individual document, much like we got access to it up above in generate auth token. We created a variable, lowercase u user, and set it equal to the value of this. That's exactly what I'm going to do right here. We'll make a variable user, setting it equal to this, and now we can go ahead and check if the password was modified. Now this is a really important thing. There's going to be times where we save the document and we're never going to have updated the password, which means the password will already be hashed. Imagine I save a document with the plain text password. Then the password gets hashed. Later on, I update something that's not the password, like the email. This middleware is going to run again. That means we're going to hash our hash and the program is going to break. What we're going to do is use a method available on our instance called user.isModified. IsModified takes an individual property like password and it returns true or false. It returns true if password is modified. It returns false if it's not. And we only want to encrypt the password if it was just modified, which means we can wrap this inside of an if condition. If the user is password modified function returns true, we're going to go ahead and run some code. This is where we're going to hash the password. If it is not modified, inside of the else statement, we'll simply call next, moving on with the middleware. Now, if the password is modified, this is where we want to add our two calls, the call to gensalt and the call to hash. Before we can call either of them, we do have to load them in up at the top of the file. Just below low dash, I'm going to create a new constant called bcrypt, and we'll require it just like we did in hashing.js. Require bcrypt.js. Now that we have it imported, it's time for you to complete the rest. This is going to be your challenge. You already know how to create a salt and how to hash a password. You have access to the password via user.password. So instead of referencing the password variable like we do here, you would reference user.password. Now, once you have the hash value after you call bcrypt.hash, you're going to set it on user.password. User.password is going to equal the hash value. Then you're going to go ahead and call next. You have to call next after you set that value. Otherwise, the middleware will never complete. All you have to do is fill out the rest. You have to call the gensalt function, you have to call the hash function, and inside of the callback for hash, you have to add these two statements. Once you're done, I want you to start up the server and make a call to sign up a new user inside of Postman. Once you have the call completed and you get a 200, you should be able to head into RoboMongo, view the record, and you should see the hashed password as opposed to the plain text password. Also, feel free to wipe your database using RoboMongo since we do have users with plain text passwords in there, and it's a good idea to make sure that you don't have any old stray documents in there that's going to cause any errors in the future. Take a moment to knock this out, test it, make sure the stored password is the hashed password, and when you're done, go ahead and click play. How'd you do? Hopefully you were able to integrate the bcrypt algorithm into this middleware. The first thing I'm going to do is generate a salt using bcrypt.gensalt. And we're going to set it up exactly like we did inside of our hashing file. We're going to pass in 10 for the rounds, and then we'll have our callback. Here, we're going to get the actual salt value, and we'll be able to use that to call hash. Next up, we are going to call hash bcrypt.hash, passing in our three arguments, the first being the plain password, which you have access to via user.password. The second being the salt, we have that in the salt variable, and the third being our callback function. This is where we get the actual hash value. Now, once we have the hash value, we're going to need to update the user document by setting user.password equal to the hash. Remember, the user password property was just equal to the plain text password, so we have to override that in order to properly hide the plain text password. Then we're going to call next, which is going to complete the middleware, and it'll move on to save the document. The next thing you needed to do after completing this was test it out. Over inside of the terminal, I'm going to shut down my server. It already is shut down, so I can move into RoboMongo and wipe my database. Now back in the terminal, I can start it up using node server.js, and we can make a Postman request. Over inside of Postman, I'm going to make a post users request to sign up a new user. And since I just wiped the database, I can use my default data right here. Notice the plain text password, it's password followed by an exclamation mark. Now, when I send this off, we still get a 200, and we can't quite tell if it worked or not because the only data we get back is the ID and the email, which hasn't changed based on the code we just wrote. In order to make sure the password is getting hashed, I'm going to head over to RoboMongo, refresh my connection to get access to that to-do app database, and I'm going to explore the users collection. Inside of here, I can view my documents. I have one document, and right here, you see the hashed password. And this is fantastic. The plain text password is no longer in sight. Instead, we're storing the hashed password. So if someone does get access to this value, they're not going to be any closer towards getting the user's password. Now that we have this in place, we can go ahead and make a commit. Over inside of the terminal, I'm going to shut down the server, run git status, and right here we have our 3 changed files. I can then run git commit with the AM flag to make a message. A good message for this one is hash user password before saving. I'm going to make the commit, push it up to GitHub, and that is it for this one. That is it for this one. I will see you next time where we start testing those 2 routes. We're going to kick things off by updating how we seed the database. That's coming up next, so stay tuned. I will see you then.